The circle is set of points of a plane which are at constant distance from a fixed point in the same plane. The fixed point is called the center, like point M in this circle, and the constant distance is called the radius length. Any circle divides its plane into three sets of points. Points outside the circle, like points X, Y, and Z. Set of points on the circle, like point A, point B, and point C. Finally, set of points inside the circle, like point M, E, and D. What is the surface of the circle? Surface of the circle is set of points of the circle union set of points inside the circle. The circle and inside it. In the opposite figure, number 1, straight line AB intersect circle M equals. Okay, the circle is the closed curve only. Then straight line AB intersect circle M at 2 points, point C and point D. We can write it inside 2 brackets of the set, point C and point D. Okay. Number 2, straight line AB intersect surface of circle M. Surface of circle M. Yes. This part, this is line segment CD. Line segment CD. Number 3, M doesn't belong to circle M. M belong to what? Yes, M is not on the circle, but M inside the circle. That means M belong to surface of circle M. Surface of circle M. Okay, look to this figure. This is circle M. Its center is point M. Line segment MA and line segment MB and line segment MC. Each of them is called radius of the circle. All radii in the same circle are equal in length. Radius of the circle is line segment with one end point at the center and the other end point on the circle. Circle has infinite number of radii. All of them are equal in length. In this figure, line segment AB is called the chord. The chord is a straight segment whose end points are any 2 points on the circle. in this figure, this is called diameter. Diameter is chord passing through the center of the circle. Diameter is the longest chord in the circle. Diameter equals 2 radius length. Look to this example. Circle M, MA and MB are 2 radii, then they are equal in length. In this case, triangle MAB is isosceles triangle. Then the two base angles are equal in measure. Then measure angle B equals also 40 degrees. To find measure of angle M, x degree equals 180 minus 40 plus 40 equals 100. In figure B, measure angle, reflex angle AMB equals 220. Then the measure of angle AMB equals 360 minus 220. Equals 140. This angle is 140. And the triangle is isosceles triangle. Why? Because MA and MB are 2 radii. Then, to find value of y equals 180 minus 140 over 2. 180 minus 140 over 2 equals what? Equals 20 degrees. Any straight line passes through the center of the circle is line of symmetry of the circle. Circle has infinite number of line of symmetry. What about semicircle? Semicircle has only one axis of symmetry. This is very important note. Important corollaries. 1, 2, 3. From 1, the straight line passing through the center of the circle and midpoint of any chord of it is perpendicular to this chord. Figure 2. The straight line passing through the center of the circle and perpendicular to any chord of it bisects this chord. Number 3. The perpendicular bisector of any chord of a circle passes through the center of the circle. Exercise number A, circle M, and line segment AB is a chord. C is midpoint of segment AB. Then MC perpendicular to segment AB. This angle, its measure is 50 degrees, and measure angle ACM is 90 degrees. Then measure angle MAC equals 180 minus 50 plus 90 equals 40 degrees. Number B, D is midpoint of segment AB. Then MD is perpendicular to segment AB. E is midpoint of segment AC. Then segment ME is perpendicular to segment AC. Figure ADME is quadrilateral. The sum of measures of its interior angles equals 360 degrees. Then to find the measure angle DME, 360 minus open bracket 90 plus 90 plus 60 equals 120 degrees. Figure C, circle M, AB is chord, segment MC perpendicular to segment AB, then C is midpoint of segment AB. AB equals 8, then BC equals 4 centimeter, and AC equals 4 centimeter. To find length of MB by using Pythagoras theorem, MB is the hypotenuse, then MB equals square root 3 power 2 plus 4 power 2 equals 5 centimeter. Example, in the opposite figure, M is circle, line segment AB parallel to line segment CD, X is midpoint of segment AB, and ray XY, XM or XY drawn to intersect segment CD at Y. Prove that Y is midpoint of CD. Okay. First, since X is midpoint of segment AB, therefore, straight line MX is perpendicular to line segment AB. Since segment AB parallel to segment CD and XY straight line intersect them, then straight line MY also perpendicular to segment CD. Therefore, Y is midpoint of line segment CD. Another example, in the opposite figure, ABC is triangle inside a circle with center M. Line segment MD perpendicular to line segment BC, and line segment ME perpendicular to line segment AC. Prove that first segment ED is parallel to segment AB. Second, perimeter of triangle CDE equals half perimeter of triangle ABC. First, since segment MD perpendicular to segment BC, therefore D is midpoint of segment BC. Similarity, since segment ME is perpendicular to segment EC, therefore E is midpoint of segment AC. In triangle ABC, D is midpoint of segment BC and E is midpoint of segment AC. Therefore, segment ED is parallel to segment AB. You studied it before in first prep. And also, length of segment ED equals half length of segment AB. Okay? From 1 and 2 and 3, perimeter of triangle equals sum of its three side lengths. Then perimeter of triangle CDE equals CD plus CE plus ED equals CD equals half BC and CE equals half AC and ED equals half AB. Take half common factor, then half multiply by CB plus AC plus AB. This is perimeter of triangle ABC. Therefore, perimeter of triangle CDE equals half perimeter of triangle ABC. Thank you.